Welcome to Insight Builder channel, Large Language Model Automators, Python experts, and my dear friends. LOTR, Chef of all retrievers. Mixing, cooking, filtering, multi-retriever outputs from the large language models. We are going to talk about LOTR, that is Lord of the Retrievers. So that is one of the new merger retriever that has been created by Langchain team, where the data from two different sources. For an example, I'm going to talk about video games and I'm going to talk about specifically about BioWare games. Then I can connect these two sources into different embedding vector stores, and then I can implement a filter pipeline and then finally get the output. So we'll be seeing the implementation in a couple of minutes, but I want to talk a bit about the reason why. What kind of challenge this particular LOTR, that is Lord of the Retrievers, solves. So what happens is there has been a lot of discussion on various kinds of retrievers. So if you guys are new to this large language models, Langchain, and the entire AI ecosystem using Python, then I would suggest that take a look at this series of videos where I discuss about various open source tools as well as the integration with Langchain. And this particular also the my channel also has other playlists that discusses about working with Langchain too. So there you will see a lot of discussion on the vector stores. You will see a lot of discussion on how to use embedding, retrievers, etc. In this discussion, whatever we are going to do is we will actually implement the lot of the retrievers using Langchain, and we will be using MakerSuite, that is Google's generative AI team's large language model interface. So let me go back to the browser for a second, and this is the MakerSuite we will be using. And if you guys have not signed up or requested for the MakerSuite access, do request for the access. It is still in the waitlist, so once you start requesting the access, you will start getting it. It will take 20 days or so odd time. I think now it is much more faster. So we'll be using this suite, and we can get the API key here. And what we are going to do is this particular repo contains the code that I will be using in this discussion, and it is already shared here, so you don't need to worry about it. It will be inside the code script notebooks. Let me dive into the discussion. So what I will be doing is, this is one of the text document that I will be embedding, and also there is one more blog on things not strings by Google. So that blog also I will be embedding. So this is the entire Google Colab notebook. So you have to just come here and upload the notebook, and you have to give the GitHub link that you can use it for. That I will be sharing it over the YouTube description below, and you can use that here for getting this code that you see here. This particular line is bringing in all the necessary libraries, including OpenAI, FAIS, Google Generative AI, Sentence Transformer. We will not be using OpenAI, so I have still used it. If you guys want to use OpenAI, you can use it. Only thing is you have to change the OpenAI embeddings. You need to change the OpenAI LLM, etc. So it's straightforward, nothing new. The Google API key will be provided here. The API key that you get from MakerSuite will be provided here. And now these are the various classes and primitives that we download or import into our execution environment. We have the retrieval QA with sources and retrieval QA chain. We have load QA with sources chain. We have Google Palm embeddings. We have conversational retrieval chain. So we'll be using all these things. And you might be wondering, but where is the lot of the retriever class? We will be discussing that in a couple of minutes. Before that, I want to set up the entire environment so that you can understand you can replicate it with your own data and your own setup. So let me go back to the presentation for a moment. So I believe that you will like these contents. Do leave a like and share it with others. Importantly, subscribe to my channel for further updates on similar kind of videos on large language models, artificial intelligence, and Python ecosystem. Always I insist on practicing, and this video is no different. So the code has been shared with you guys, as well as the LOTR merger retriever link has also been shared with you. This particular presentation also will be available in the GitHub repo, so you can download it under the presentation folder. The reason why I request for you guys to practice is, let me go back to the browser. Once you, most of the abstractions, here all these things are abstractions. You see here this classes that has been downloaded. These are all abstractions around the services like the LLM APIs, or it is abstraction like phase around the databases, which is actually files that is inside the inside your drives, and also various other kind of primitives like chains and memory, conversational memory, the retrievers, etc. Now, what we are going to do is we are going to use phase for the vector embedding. It's very simple and it's very straightforward to use. It has no bells and whistles. All you need to do is give it the text, it will embed it, and then it will store it as embeddings. So it has been created by Facebook. A huge shout out to Facebook AI team. Okay, what you are doing is we are going to use a couple of embeddings here. So we are going to use open source Hugging Face embeddings also, and you will be using Google Palm embeddings also. So I'll be telling, going through one by one right now. So this particular text is from Introducing Knowledge Graph, Things Not Strings, the blog about that. So this text talks about knowledge graph, especially on connecting things using connecting entities inside the text data. That is what this particular text talks about. And next is the Atlas, how Atlas works. Atlas is a kind of a vector embedding data store. Again, it's also a database, but a different kind of a database. I'll be having a complete video on this particular product, and also the benefits around it, but here I am not going to discuss about Atlas. I'm just showing that I'll be using a part of this Atlas documentation in this text. As you see, this text is a little bit longer when compared to this text that we have. So usually if you have come across the various videos till now, you must have come across multi-router retrievers or multi-chain retrievers where two different vector stores can be connected together. Here what happens is, let me come further. So here what I'm doing is I am using a recursive character text splitter to split the text above, and then I'm embedding. So when I'm embedding, what I'm doing is I'm using two different sentence transformers open source embedding functions. So this is how you get the open source embeddings, and I've named the functions as embeddings 1 and embeddings 2. For embedding the Google things not strings, I'm using the all MNLI all mini LM, that is embeddings 1, and for using embedding the Atlas documentation, I'm using the multi-QA process, multi-QA embedding. These two are going to be different data stores. So here I'm saving the data stores, that is phase database, I'm saving it locally and then zipping it. So in this way we can avoid doing this again and again. And if you're going to run this, so this particular notebook will have the zip files. This zip files will be available inside the GitHub repo also. You can use that, or you can actually use this notebook and you can make it. It will not take a lot of time. Moreover, it's open source. You are not going to spend anything. And you please keep this in mind. So these are two open source embedding functions, and they have a different vector length. So this has a different vector length. Both are around 786 vector length. While as we go forward in this discussion, we'll be using Google embedding, which is also 786. And instead of Google embeddings, if you are going to use OpenAI embeddings, which is 1536 vector length also, it will still work. So this is one of the aspects I want to highlight. In most of the other retrievers, if you change the embedding function, it will not be able to retrieve. But in case of LOTR, it will be able to retrieve. So that is the idea that I want you guys to take home. So here is where I am creating the retrievers, and I am using, in one case of the retriever, I am using similarity search, and in another case I am using the marginal retrieval method strategy, and both of these retrievers I am going to use it next. So this is where I am bringing in the merger retriever. So this is the LOTR retriever that I was talking about. So if you thought that okay, there will be a retriever named LOTR, sorry about that, it is called as merger retriever. and there will be redundant filter class, and we'll be using document compression pipeline, and we'll be using contextual compression retriever. So all these retrievers or all these classes are trying to work with the data that has been retrieved from the vector stores, and then they either compress it or they filter it. So when we say compress it, it is going to summarize the information. When we say filter it, it is going to throw away some of the unwanted documents. So all these things, it is going to happen inside the abstraction. So you will not be able to see what is going on inside. So you will give a query, and out will and reply will come, but you will really not understand what is going on, how the query is getting responded. So I will try to provide as much information I can, so that it will be easier for you to understand. Let me proceed. So now we already know how the retrievers are coming, okay, how the retrievers are created. If you want, you can actually run a retrieval here. So for an example, if I say retriever add, and I say get relevant document, get relevant documents, and I talk about embedding vectors, and I'm making up something, and I'm expecting. So you see that we get 4 or 5 documents out, and all these are talking about various embeddings, right? And similarly, you can try with data, the retriever PNS also. I have kept the names in such a way that it is easy for me to change it. So here you see for the same embedding vectors, we are actually getting different answers here. It is completely different, and it is nowhere linked with what we want. In case of embedding vectors, whatever we got from Atlas is more relevant to what we are getting it from this particular text data. Where is it? This particular text data. But still, how is this going to, how the answers are going to come out? So we will see that in a couple of minutes. So what is happening is, I am creating the merger retriever where both the retrievers, both the retrievers are merged together as a list. So it's not something you are going to do manually. It is done for you by the merger retriever, and then the actual fun starts. So here is where the redundancy filter is created. So this embeddings is actually Google embedding. So if you go up, way up, yeah, if you go up here, you will see that it is actually Google Palm embedding. So whenever you are trying to use any kind of filters, try to use a better embedding or a better model. So Google embedding is much better. So use that when compared to these open source. That embeddings is much better. Use that, and we will then send it through the compression pipeline, where the transformation happening is the filtering. So after that, what we do is, we are going to use this pipeline inside the contextual compression retriever, and we are going to use the LOTR retriever, this retriever. You see this? So this is actually a retriever. So for an example, if you come here, sorry about the disturbance. So if you come here, and if I create get relevant documents, and you will see that I am getting around 10 documents as output. So this is collecting the outputs from both the retrievers, and it is giving it to me as a single bunch. After that, what happens is, the filtering happens, the compression happens, and then we are going to get the relevant query here. So what we are trying to do here is, so here this is a compression retriever, right? And I'm going to give this query. So this is different. So this LOTR is basically a merger retriever, while this compression retriever has other filters already kept here. So this compression retriever is not same as LOTR. Keep that in mind when you are going through all this abstractions, classes, and functions, right? It is very easy to get lost in context. So that's why I'm going back and showing you what is happening here. And when I actually run this particular code, what will happen is, I will start getting the entire embedding also, and you see the embedding, the vector is also getting returned to me, and you can actually take a look at the data. So the data that I get out is not actually 10 in number. So let me check the length of this list. So once you take, so we are having 10 documents that is coming out that is deemed as relevant by the compression retriever. Next, what you are going to do is we are going to take this retriever and we are going to use it in retrieval QA chain. Now, this is where the document that is given by the compression retriever is going to be again be filtered by the large language model. So in this case, this is Google's Palm large language model. Till now you are talking about the embeddings, Google Palm embeddings, but here it is the Palm large language model. And all these large language model embedding, everything is controlled by the single API key. So you don't need to think about how these things work. It is all controlled by single API key. And after that, after I create the retrieval QA chain, I am going to create a kind of a LLM chain also just to compare. So this retrieval QA chain has the compression retriever as the support, while this LLM chain has got only the large language model. It does not have any of the vector database support. So why I'm doing this? To show you the comparison. If I go, so this is the query that I'm sending. So the query is explain about embeddings. So this is the query, and I'm sending it to the LLM chain first. So this LLM chain does not have the vector store backup, as I already explained to you. And you see that it is explaining what is embeddings in a from whatever it has learned already. Whatever Google Palm LLM has learned, it explains that. But now I'm using the QA endpoint query. So I'm using this this QA endpoint, which has the retriever for the compression retriever. And now you see the answer is concise. You see the difference when you are going to use just the LLM and when you are using the compression retriever along with the merger retriever, the answer is very precise. And it is also you can test some more. So I am actually testing it with what is knowledge graph. And you see here the answer is from the LLM chain is a semantic network. But when I test it with query 1, you get a little more nuanced answer. So this actually is getting the information from the data that we have already provided to it. So that we can clearly find it out, right? So this data, the data we have provided as a backup that is already available as an embedding in the vector store, that is getting used here. So a couple of more examples I have tried, and next is something much more interesting. So what I decided is that, okay, let me bring in one more primitive or classes that is created by Langchain, that is conversational buffer memory. So whatever conversation you are having, you can actually store it, and irrespective of what LLM you are having, you can actually store the conversation. So here I am creating the conversation buffer memory, and the memory key is stored as chat history. After that, I am sending the conversational retrieval chain along with the LLM, the compression retriever that we created, and the memory that I started here. And then I start asking the same questions. The key difference is when I come to this query. So when I come to the last query, I ask, okay, summarize our discussion. And you see the final output. So the assistant explained to human the embeddings are vector representation. So it starts discussing about embedding, and then the assistant showed to the human how to use knowledge graph to search for information. So it has summarized the entire discussion that we are having, and it provided a concise reply. I hope that you guys were able to see it. If not, sorry about that. I believe that it will be the data is already available in the GitHub repo, so you'll be able to take a look at that. So let us go back to the presentation. I believe that you have got some clarity on how the merger retriever, the various kinds of vector stores can be brought together and converted into a kind of a la carte. So that's why I was talking about cooking. So when you are actually going to create a kind of an answer to a question or create a report or going to work with a complex set of information that is going to come from different sources, then working with such kind of merger retrievers is going to make your life both easy as well as complex. Why I say complex? Because you have to understand what is the capacity of these kinds of merger retrievers, and you need to actually do a lot of practice. You need to work with various kinds of data sets. You might have to also work with the data formats in which you are going to feed the embedding as well as the embedding into the vector store. So all these things is important. And with that said, I believe that you have learned something. So do practice with this particular code, and do let me know if you have any questions or comments. I will try to provide as much feedback as possible. And one more point I wanted to add. Let me go back to the browser. This point I missed to discuss. When you are creating this conversational buffer memory, internally it actually initiates a dictionary. So this conversational buffer memory has nothing to do with the large language models. So this is purely a Python class which internally creates a dictionary, and that dictionary contains two information, that is AI message and human message. And in turn, AI message and human message are themselves classes. So you see what is happening in case of Langchain. It is a series of abstractions on top of simple strings. If you think about it, if you actually go into the code of Langchain, it's actually made of prompts. It is made of various kinds of classes that have different kinds of prompts. I have been insisting on this on all my videos. Once you go to the actual Langchain repository and go through in fact, to bring to the notice, if you go to the Langchain documentation, you may not be able to find out the Google Palm LLM as a integration in the large language model, or the Palm embedding as integration. The reason is still the documentation needs to be updated. So how did I get to know about how to initiate this LLM? All I had to do was go to Langchain repository, look into Langchain folder, and I found that okay, Google Palm is already the class abstraction for Google Palm is already written, and I have to just import it. So sometimes even if the information is not in the documentation, you can always go to the repository. Since it is open source, you can always check the repository, understand the code, and then you can start using it. So this is one of the one of the key aspects I always talk about in my videos. It's about solving series of problems, and once you solve the problems, you will get more confident and you will look for a better challenge. I believe that you like this content. Do leave a like, share it with others, and subscribe to my channel for further updates. With that said, I would like to leave this video with 4 words, that is practice, practice, explore, explore. See you guys. Have a great time.